Greetings from K.S.Rangasamy College of Technology. I am K. Raja, Faculty of Mechanical Engineering Department, K.S.Rangasamy College of Technologies. In this video, I am going to discuss about the belt drives. So what is mechanical drive? The power has to be transmitted from one shaft to another shaft. Here there is two shafts, one is called pedal shaft, another one is called rear wheel shaft. So the power from the pedal shaft is transmitted to the wheel shaft by means of an chain drives. So this is called the mechanical drive systems. So type of mechanical drive systems. The mechanical drive system is broadly classified into two types. One is called flexible drives, another one is called a direct drive. Under the flexible drive, belt drive, rope drive, under the chain drive. On the direct drive, there is gear drive under the cam drive. So some of the example of flexible drives under the direct drives are there. In gear train, we can find that examples that is called a practical application. We can see in the gearbox and the differential we are using a gear drive. It is called direct drive. So we can see the chain drive on the bicycle and the motorcycles. On the belt drive, you can see this type of belt drive on the rice mills. Your rope drive, you can see on the lift and the crane. You can find that this type of drives. So first thing, what is the difference between flexible drive and the direct drives? You can see this is called the flexible drive. This is a direct drive. So flexible drive, we take it as a belt drive as a flexible drive. Here there is a drive shaft. Another one is called the driven shaft. So the power from the drive shaft is transmitted to the driver pulley. Then that rotary motion is transmitted to the belt by means of frictions. The belt is moved on the translatory motions. That translatory motions causes the driven pulley to started to rotate. So the driven pulley is rotate, then the driven shaft is also rotate. Here the flexible element is the driven, that is called the belt. Belt is a flexible element, so it is called the flexible drive. So why we name it as a flexible drive means, so in the things in the flexible drives, the center distance between drive shaft and the driven shaft is not at a constraint node. So there is some little bit adjustment is possible there. Another thing, it is called the longer center distance, it is possible on the flexible drive systems. But in the direct drives, the drive system is directly connected to the drive shaft and the driven shaft. So here we can only achieve the highest most gear ratios, and also there is no slip is happened between that power transmission. But here it is slip and the creep is also happening. It reduces the power transmitted capacities. So flexible drive having some advantages and also having disadvantages. But in the direct drive, the center distance is minimum, but in the flexible drives, we can make it the center distances on the maximums. So based upon our requirement, we can select the direct drive or on the flexible drives. So selection of conditions for selections of the drive systems based on the speed ratios, the speed of the driving and the driven shaft, and also the how much of power to be transmitted between the drive and the driven shaft, and the based on the positive drive requirement, if there is no slip or if we can allow some slip, and also the space available between the drive shaft and the driven shaft, speed ratios, and important things, the space and the center distance between the shaft and the shaft layout, and the conditions on the position of the shaft. The shafts are parallel or the shafts are perpendicular and non-intercepting non-parallel shaft. As on the position, we can select the drives, and also on which conditions we have to transmit the power. So the service condition is also an important criteria of selection of the flexible drive or on the direct drives. So first thing, what is belt drive? So here we can see that is a belt drive systems. So belt drive is consisting of the pulleys, shaft and the belt. The belt is a power transmitting systems. The pulley is mounted on the drive shaft and also on the driven shaft. So the pulley, the drive pulley and the driven pulley is connected by means of an belt. So here there is a rotary motion is converted into the translatory motion on the belt drive. The power transmitting capacity is depend upon the velocity of the belt and the tension of the belt and the arc of contact between the belt and the smaller pulley and the conditions under which the belt is used. So these are all the parameters affect the power transmitting capacity of the belt drive. So terminologies of the belt. So terminologies, here we are having a smaller pulley and the larger pulley. So the smaller pulley, and this is called the angle of contact. So the theta is the angle of contact where the belt is contact with the pulley. So it is the angle of contact, and this is the center distance between the two drive. So drive pulley and the driven pulley, this is called the center distance, and also the thickness of the belt. So thickness of the belt, and this is the pitch line of the belt. So these are all the parameter to be considered for finding out the power transmitted capacity and also finding out the terminologies of the belt drives. So what is the law of belting? The law of belting, when the pitch line is moved towards on the pulley, it leads to the perpendicular positions when it reaches the pulley. You can see that the pulley center line and the pitch lines are on the perpendicular positions when it reaches to the pulley. So this is called the law of belting. If the law of belting is not satisfied, the belt is come out from the pulleys. So that will happen. So what are the main formula we have to find out on the belt is called velocity ratio. First thing we have to know about which one is drive pulley and the which one is driven pulley. The drive pulley is where the power is to be taken, the power prime mover is attached, so it is called the drive pulley. And the driven pulley is nothing but where the power to be transmitted, that is called the driven pulley. So first thing you have to find out the which one is called a drive pulley and which one is driven pulley. Then we can find out the velocity ratios, n2 by n1. So n21 is the speed and the n1 is the smaller speed. So you can see that the n1 and the n2s are the speed of the drive pulley and the driven pulleys. Next we can find out by the d by d. So capital diameter and the diameter ratios of the drive pulley and the driven pulley, or speed and the angular velocity of the drive pulley and the driven pulley. When we consider the thickness of the belt, that to be added to the pulley diameter, so that the pulley diameter also increasing. So this, if you consider the thickness of the belt. So material of the belt, so different materials we can use. So first thing, leather belt, cotton or fabric belt, rubber belt and the synthetic materials. So before selecting the belt, we have to consider these are the point. First thing is the belt material should have high coefficient of frictions with the pulleys. So there is a less power losses is happening and also slip is happening. So that material should be have high coefficient of friction. Another thing, the belt material should have high tensile strength to withstand the belt tension. So the belt is working based upon that tensions. So that tension will not makes the belt material to break failure. So that belt materials to withstand the tension. Another is called the belt material should have higher wear resistance. So the belt is directly contact with the pulley and there is a friction is also there. So that it will be a high wear resistance. So the life of the belt should be longer. And the belt material should have high flexibility and the low rigidity in bending in order to avoid bending stress while passing over the pulley. So if the belt is passing over the pulley, there will be a bending stresses acting on the belt, that to be also withstand by the belt material. So before selecting the belt material, you have to consider these points on selection of the belt materials. So type of belt based on the construction of the belt. So there is a flat belt. When we cut the cross section of the belt, it should be on the flat. It is called rectangular cross sections. When we cut the belt, if the belt is having a V belt cross section, it is called the V belt. And if the belt is having a circular cross section on the circular belt, based on the cross section of the belt, the pulley is also designed. So if the pulley flat belt, there is a flat pulley is there, and if this V belt, there is a grooves on the V grooves on the pulley, and also if a circular belt, and also the V grooves on the pulley. So based on the cross section of the belt, the pulley is also designed like that. So type of belt drive. So if you have belt drive as a different type based on the position of the shaft and also the position of the belt over the pulley. This is called the open drive. So it is normally used here. The clockwise direction is transmitted into the clockwise directions of the driven pulley. The driven pulley and the drive pulley both are rotated in the clockwise direction. If we want to rotate the both pulley in opposite directions, means we have to use this cross belt. So cross belt here, the clockwise direction of the pulley is converted into anti-clockwise direction of the pulley. This is called the cross belt drive is used when we want to change the direction of the motion from drive pulley to the driven pulley. Like that, if you want to transmit it the power between this 190-degree position of the shaft, here this is the drive shaft and this is the driven shaft, both are in the 90-degree position and non-intercepting, that is called the quarter turn belt drive is used. So this is called one of the things is there. Another here, it is also the position is 90 drive, but the axis is on the intersection positions. We can use the idler pulley to increases the tension on the tight side. Okay, so that's we call to the quarter 10 drive pulley with the guide pulley. Here it is the idler pulley we are using here. So why we are using the idler pulley? Means we have to increases the tension on the tight sides. So if you are increasing the tension on the tight side, means automatically the power transmitted capacity is also increased. So this is, you can see this kind of constructions on the front side of the engines. So you can see there is a built different, the one single belt can be used or multiple belt can be used to transmit the power between the shaft, and also the tensioner or idle pulley are also used there. In some cases we are using a flat belt, or on the V belt we can use for that conditions. This is called the compound drives. So from that construction you can understand, from that drive pulley is transmitted power to the driven pulley. On these conditions the driven pulley is considered as a drive pulley and it driven the another pulley. So this is called the compound drive. So this is the multiple drive with the idle pulley conditions. Based on the applications requirement and the center distance and the velocity ratio and the power transmitted capacity, we can select the different type of drives, belt drives. So slips under the creep. So this is the negative effect when we are using on the belt drive system. Why the slip is happening here means the drive pulley transmitted the power to that belt by means of an coefficient of the frictions. So there is some relative motions. So there is some relative motions between, if there is insufficient coefficient of frictions and the coefficient of friction is not enough, means there is a slipping is happen here. Slipping is nothing but the power losses is happen between the pulley and the belt. So it will reduces the power transmitted capacity and the losses is happening because of the frictions between relative motions and the friction between the pulley and the belt. And the creep is happening here. So why the creep is happening here means there is a changes of length of the belt is happening when the belt is moved from tight side to the slack side. When the belt is moved from tight side to the slack side, the extension is happening on the belt, the length is increasing. When the belt is moved from slack side through the tight side, the contraction is happening, so the belt length is reducing. Because of this changes of length between the tight sides to the slack side, there is some losses is happening, power losses is happening on the belt drives. So this slip and creep reduces the power transmitted capacity of the belt, that can be reduced by means of using this higher angle of contact between the driver pulley and the driver pulley, and use of the idler pulleys, and the crown can be used for making the more coefficient of friction, or using a very some other material which created the high frictions between the belt and the pulley. So thank you very much for listening these videos. So keep learning and growing. Thanks from K.S. Rangasamy College of Technologies.